Typically, when you get into the study of functions, eventually what you want to do is you want to graph functions and figure out what their domain and range are. So the domain is going to be the set of all possible x values, or inputs, of a function. And that's going to be the set of all x values. So typically, you're going to be looking at the x-axis. The x-axis, that's this horizontal axis that goes from left to right. And the range is going to be the set of all possible y values, or outputs, of a function. Sometimes you'll hear it called range, sometimes you'll hear it called outputs, sometimes you'll hear it called y values. But for this, you're going to be looking at the y-axis. That's the vertical axis that runs up and down. So we're going to be using domain and range to characterize these functions. So I have right here a graph of the function y equals x squared. And what I want to do is I want to find the domain of this function and the range of this function. So when we think about domain, we write down the word domain. And then what we want to do is we want to think about what x values does the graph take up. And when you look at x values, no matter which x value you put into the function, you're always going to get something out. You're always going to associate an output with an input. So the domain for this is going to be all real numbers. All real numbers. And what that means is any real number can be an input for this function. And typically we write all real numbers. The same way of writing that would be R, capital R. R is used to denote the set of all real numbers. So R is going to stand for every single real number in existence. So if that's the domain, then now let's find the range. Remember that the range is the set of all possible y values of a function. So what about the y values? What y values does the graph take up? Well, when you look at the y values, you really start right here at 0, 0. This would be the point 0, 0. So you're starting at 0 and you're going up, right? Every single point is either at 0 or above 0. So when we write the range down, we want to think of y values. And the y values is going to be everything greater than or equal to 0. So I get y is greater than or equal to 0. And that's because y can be 0, but it could also be greater than 0, because that's the y values that this graph is going to take up. So you can write it as y is greater than or equal to 0, or you can also write it in set notation, right? You can write it as bracket 0 to positive infinity. And then I close up the brackets with the parentheses. So what this closed bracket does is it includes 0 in our range. And any number that's greater than 0 is in this set as well. And then when you ever use positive infinity, or if you use negative infinity, you have to close it up using parentheses, because infinity is not a real number. It's more like a concept. So that is domain and range. You're always thinking about what x values does the graph take up and what y values the function takes up. So now let's look at our next example. F of x equals x cubed. And when you graph it, you get this shape. This shape that extends all the way from the bottom, goes to 0, and then goes all the way to the top. So let's think about the domain first. What x values does the function take up? Well, the graph is going to continue to go left if you go down, right? And the function is going to continue to go to the right as you go up. So the domain is R, or all real numbers. All real numbers. So that just means that any real number can be put as an input into this function. and you will receive an output. Which brings me to the range. Let's talk about the range now. Range is the set of all y values that the function takes up. And which y values does the function take up? Well, it goes from the bottom and it goes all the way to the top. So the range is also going to be r, or all real numbers. So any y value for this is going to be a part of the range. Any real number that I can think of will belong to the range of this function. So that's f of x equals x cubed. Let's move on to the next one. Okay, now this one is the square root of x. So if you were to graph the square root of x, you get the square root function. And it starts at 0 and it goes all the way to the right. It goes all the way to the right, all the way to positive infinity. So if you want to think about it that way, the domain is going to be from 0 to positive infinity. From 0 to positive infinity, right? It goes to the right, not the left. So negative numbers are not going to be a part of the domain. So you can think about it as from 0 to infinity, or you can also think about it as x is greater than or equal to 0. Since x can be equal to 0 right here, but greater than that, x has to be greater than 0. So that's the domain. Now let's talk about the range. What y values does the function take up? Well, for y values, it starts at 0, and then the function goes up from there. So the range is going to be y is greater than or equal to 0, or from 0 to positive infinity. Close it up with parentheses. And that is the range of the square root function. Okay, and the last one we'll do, this is just going to be a line. So what's the domain of this line? What x values does it take up? Well, this line is given by the function f of x equals x plus 2, or y equals x plus 2. So which x values does the graph take up? Pretty much every single real number, because the graph is going to continue going to the left and down, and the function is going to continue to go to the right and up. So the domain is going to be R, also known as all real numbers. All real numbers. So that is the domain. The range is going to be the set of all y values, right? What y values does the graph take up? Well, pretty much every single one. So just like the domain, the range is also going to be all real numbers, also known as R. All real numbers. So that is the domain and range. You're always thinking of which x values does the graph take up, which inputs can be put into the function, what is the function defined for. All those questions will help you figure out what the domain is. And when you think about y values, you're thinking about what are the outputs of the function, and that is going to be the range.